I welcome you all in the third lecture on Introduction to Cams and Followers. Once the desired motion of a cam and follower has been defined through a displacement diagram, the actual shape of the cam can be designed. The shape of the cam depends on the size of the cam along with the configuration of the follower. Prior to designing the profile of a disk cam, some geometric features must be defined. These features are called as cam terminology. In the figure, you would see a radial or disc cam which is in contact with a roller follower. Of course, the line of movement of the radial follower exactly passes through the center of rotation of the cam. The bold profile, the dark bold profile shows the actual cam profile here. So we are going to define the first term that is used in the terminology of the radial or disc cam is the base circle. So base circle is the smallest circle which is tangential to the cam profile and it is drawn from the center of rotation of the cam. Trace point is a reference point on the follower and is used to generate the pitch curve. The trace point serves as a reference to determine the effective location of the follower. In case of knife edge follower, the knife edge represents the trace point and the pitch curve corresponds to the cam profile. In a roller follower, the center of the roller represents the trace point. Third important term which is used in the radial cams is the pitch point. It is a point on the pitch curve which is having the maximum pressure angle. As you would notice from the figure that as the cam undergoes a rotation, it basically imparts a force on the follower in a direction which is normal to the cam profile at the point of contact. So obviously this pressure angle is different on different point along the actual cam profile. Fourth one is the pitch circle. It is a circle which is drawn from the center of the cam through the pitch point. Pitch curve is nothing but the curve which is generated by the trace point as the follower moves relative to the cam. For a knife edge follower, the pitch curve and the cam profiles are same, whereas for a roller follower, they are separated by the radius of the roller. Prime circle is the smallest circle that can be drawn from the center of the cam and it must be tangential to the pitch curve. For a knife edge and a flat face follower, the prime circle and the base circle are quite identical. And for a roller follower, the prime circle is larger than the base circle by the radius of the roller. Whereas the cam profile is nothing but the actual working surface of the cam. It is the surface which remains in contact with the knife edge, roller surface or the flat faced follower. Lift or stroke is nothing but the maximum travel of the follower from its lowest position to the topmost position. From the figure, you would notice that when the follower is in contact with the circle on its top, it is basically reflecting the lowest position of the follower. It is only because of that wedge-shaped lobe which is put over that circle which ultimately results into the lifting of the follower. So the difference of these two, that is the top of the circle and top of the cam lobe, is nothing but the lift or stroke of the follower. Home position of the cam is the orientation that corresponds to the 0-degree reference position on a displacement diagram. The prime circle is always drawn through the trace points of the follower while the cam is at its home position. Heel of the cam is nothing but sometimes we also reflect the base circle as a heel of the cam, which is the lowest point of the camshaft lobe and is the place where the valve is in the closed position. The opening ramp of a camshaft lobe is the point where the lifter just begins to lift until the point that it reaches the nose of the lobe. The closing ramp is the point of the camshaft lobe from the nose back down to the lash ramp. The opening ramp takes up all the clearances in the valve train and causes the valve to be on the verge of opening. The closing ramp begins when the valve touches the valve seat and ends when the tappet returns to the base circle. Nose of a camshaft lobe is the top or the highest maximum lift point for the valve. It is where valves are kept open for as long as possible before making the transition to the closing ramp. The sides of the cam lobe, or the portion of the lobe that lies between the nose and the base, circle on either side. They are known as the flanks. They are also called the opening and closing ramps. Pressure angle is the angle between the direction of the follower motion and a normal to the pitch curve. If the pressure angle is too large, a reciprocating follower will jam in its bearings. Cams with roller followers have pressure angles, whereas the cams with flat face followers, they don't have any pressure angle. Angle of ascent is the angle through which the cam turns during the time the follower rises, whereas the angle of dwell is the angle through which the cam turns while the follower remains stationary at the highest or the lowest position. Angle of descent is the angle through which the cam turns during the time the follower returns to its initial position. The angle of action is the total angle moved by the cam during the time between the beginning of the rise and the end of the return of the follower. Let us now understand how the pressure angle varies from point to point on the cam profile. For the sake of understanding, what we are going to do is we will consider that the cam is stationary and the follower basically moves upon and around the cam. So we are basically going to take help of the kinematic inversion here. So keeping the cam stationary, there is one position of the roller follower when it is absolutely vertical. Its line of movement is along this blue line. Another position of the same roller follower when it is in contact with the cam profile is shown by the dotted position of the follower here, where its line of movement is represented by a red color line. So the pressure angle, as we defined earlier, is nothing but the angle between the direction along which the cam imposes a force. So it has to be normal to the cam profile. So for the sake of understanding, we have drawn here one green tangent line, which is a common tangent at the point of contact, and a yellow line is nothing but a line which is perpendicular to this tangent. So this is a common normal. So the cam, while it rotates, it basically imposes a force on the roller follower along this yellow line when the follower is vertical. Its line of movement is along the blue line. So the angle between this blue line and yellow line is nothing but the pressure angle. So after a certain while, keeping the cam stationary when the follower attains or acquires a new position and its line of movement is along this red colored line. Again, what we do is we draw one more tangent line at the point of contact, which has to be common tangent to the cam profile as well as the roller surface which is in contact with the cam profile. So it is represented by a new common tangent line shown by a purple color line. Another line which is a new common normal represented by a slight brown line is a line which is perpendicular to this new common tangent. The line of movement of the follower is represented by the red color line. So the angle between this common normal and the line of movement of the follower is the new value of the pressure angle. So you would clearly notice that the pressure angle has slightly reduced. So as we move along the actual cam profile, at different points the cam is going to attain a different value of the pressure angle. We have noticed that a force is always transmitted perpendicular to surfaces in contact. The cam does not always push the follower in the direction of its motion. Obviously, the curvature of the cam affects the position between the follower center line and the actual contact point. After graphically constructing a cam profile, the magnitude of the pressure angle can be visualized by observing the location of the contact point in relation to the follower center line. The regions where the cam profile exhibits the greatest curvature should be identified. Measurements of the pressure angles in this region should be obtained. There are certain observations which should be clearly understood about the pressure angle. The force required to push the follower depends on the application of the cam system. However, the contact force between the cam and follower can be much greater depending on the location of the contact point. Actually, only one component of the contact force generates the follower motion. The force exerted by a cam on the follower is always normal to the surface of the cam at the point of contact. The vertical component F cos alpha lifts the follower, whereas the horizontal component F sin alpha exerts a lateral pressure on the bearings, which must be absorbed by the follower guide bearings. The pressure angle correlates these two components of the contact force. As already described, the pressure angle at any point on the profile of a cam is the angle between the follower movement and direction that the cam is pushing it. More precisely, it is the angle between the path of the follower motion and the line perpendicular to the cam profile at the point of follower contact. Each point on the cam surface has a pressure angle. In order to reduce the lateral pressure or F sin alpha, alpha has to be decreased, which means making the surface more convex and longer, as shown by dotted line in the previous slide. This results in reduced velocity of the follower and more time for the same rise. This also reduces the dwell period for a fixed angle of action. In internal combustion engines, a shorter dwell period means a smaller period of valve opening, resulting in less fuel per cycle and lesser power production. Thus, the minimum value of alpha cannot be reduced from a certain value. In general, the pressure angle should be kept as small as possible and should not exceed 30 degrees. The magnitude of the pressure angle can be decreased by increasing the size of the base circle, decreasing the magnitude of the follower displacement, increasing the angle of cam rotation prescribed for the follower rise or fall, by decreasing the amount of follower offset, or modifying the follower motion scheme. Let us now see how the base circle diameter is going to affect the value of the pressure angle. For the sake of analysis, what we have considered here is considering the two base circles. One is the smaller base circle marked in that red rectangle. There is one more base circle having a relatively larger diameter. So these are going to be the base circle diameters for two different radial or the disc cams. The speciality of these two radial cams is that both will impart a same lift to the follower, represented by the h height, that is the lift imparted to the follower. So keeping the same lift being imparted to the follower, the cam or the radial cam with a smaller base circle diameter would require a relatively much steeper wedge to be put over this small circle as compared to the another radial cam, which is going to have a relatively larger base circle diameter. In order to impart the same lift to the follower, it will basically require a wedge having relatively larger length but lesser steepness. So definitely the size of the base circle controls the pressure angle as shown in the figure. The increase in the base circle diameter increases the length of the arc of the circle upon which the wedge, that is the raised portion, is to be made. A short wedge for a given rise requires a steep rise or a higher pressure angle, thus increasing the lateral force. The size of the base circle is typically dictated by the spatial restrictions of the application. In general, a large base circle causes fewer problems with the force transmission. However, a large base circle and hence a large cam is contradictory to the common design goal of the smaller products.